Hi, this is Mike from Mike's Unboxing Reviews and How To, and on today's video we'll be taking a look at how to set up your fans in an MSI motherboard. Now this is going to be appropriate for pretty much most motherboards. Obviously terminology and also the layout may be slightly different, but the principles should be the same. This video has been done as we've had a couple of viewers which have watched previous videos and said that they didn't quite understand some of the jargon or how things actually work and wanted a little bit more in depth. So that is exactly what we're going to try and do on today's video. So keep watching to find out more. Okay, so let's get started on today's video. So effectively what we're going to be doing today is going over fans, fan principles, how they work, how they're controlled within the BIOS and also within software, within Windows, and we're going over some of the basic principles. So hopefully this should clear up any questions or comments you may have. Obviously, as always, as I always say at the end of the videos, and it should be pretty much self-explanatory by now, if there's anything you don't quite understand, please do reach out to us either from the comment section below or from our Discord, and we'll be happy to go through it in depth with you on a one-to-one basis. So with that out of the way, let's get started. So to begin with fans. Now there are arguably three specific types of fans, potentially four. So the four types are ones which are custom cabled. So these are going to be things such as your Lian Li fans, some Thermaltake fans, Corsair, etc, etc. These are ones where they use a specific type of fan header or fan plug which attaches to either a hub or a specific kind of control module. Now we won't be going over those in this particular video. This is more for the more common types, which are the 3 or 4 pin types of fans. So the two in that particular instance are your 3-pin DC controlled fans. So these use 3 pins that plug into a header on your motherboard, and those 3 pins are, one is for voltage, one is for ground, and that is basically it. So these are controlled in voltage. The next one is going to be the 4-pin PWM fans. So these are pulse width modulation. Effectively they work in a very similar way, although there is an additional wire which sends a PWM signal to the motherboard, which allows slightly more granular control. With the voltage fans, the 3-pin ones, generally you increase the fan speed by increasing voltage up to a maximum of 12 volts. Now if we take a look at these Corsair fans here, so these are the SP120 ARGB Pros, these are 3-pin fans and are controlled using voltage. And on the back of the box, it will give you a fan speed. Normally it will give you a maximum fan speed. This one is 1400 RPM at 12 volts. So what you do is if you wanted to regulate that speed from 12 volts, you drop down to maybe 9 volts or down to 5 volts, whatever it is, to reach your specific or your intended desired fan speed. Now fan speed is controlled from voltage in both ways, PWM and for DC controlled fans or 3-pin fans. It does get a little bit complicated, but effectively the more voltage you put through a fan, the faster it should spin. Hopefully that kind of makes sense. Where things get a little bit more complicated is with our PWM fans or the 4-pin versions. So this is a fan from Gelid. This is a Zodiac fan, and what you'll find on this is it has a PWM range. So the little controller in the fan actually has a built-in hardwired basically controller which says what the highest speed and the lowest speed of the fan can be. In this particular instance, for this one, we've got a lowest particular speed of 700 RPM and a maximum speed of 1600 RPM. So regardless of what you set the fan to, if you set it to 0 in your fan control software, it's still going to spin at 700 RPM because that is the lowest speed it can go to. If you want your fans to go a little bit slower, then you need to look at the PWM range and get one which either has something called zero fan technology or specifically states that it will go lower. So this particular one from Arctic, this is their P12 PWM PST ARGB 0 dB. The 0 dB basically means this will spin down to a low speed, i.e. it will stop. So the PWM range will be somewhere between 0 RPM and somewhere up to, I think it's about 1800 RPM for these particular models. It does say on the back, yeah. So this one on the back says from 0 to 2000 RPM. So in your PWM control, you can move the slider from the very bottom, which will be 0%, up to 100%. And obviously as you move it up, it will go up in incremental sections. So 10% for this, being this is a 2000 RPM fan, should be somewhere around about 200 RPM. Hopefully that makes sense. It is a kind of gradual thing and it goes up exponentially. So as you increase, the fan speed increases with your PWM setting. Also, when we talk about things such as ramping up, so when a fan ramps up, that means that in order for the fan to actually cool your processor, it ramps up the speed or increases the speed. So if you have a particular setting, say for instance you have your full speed setting at 70 degrees Celsius because you want your processor to get its maximum cooling when you get to that sort of temperature, that is going to ramp up. So between a certain fan speed and CPU temperature, it will start off lower. As the CPU temperature increases, the fan speed increases to keep up with the temperature increase. Hopefully that makes some sense. Something else we should touch on as well is the word or the phrase fan curve. Now, fan curve is something which does complicate things a little bit. It isn't technically a curve as such, but potentially it can look like one when it's laid out in a graph. Generally, a fan curve or fan profile is basically a plotted out graph of how your fan will react to certain temperatures in the system, be it either CPU, GPU, or whatever you set your specific fan to, which we'll see a little bit later in the video. So a fan curve isn't a curve. You're not physically adjusting the blades of the fan. You're not bending anything, melting anything, removing fan blades, etc., etc. The fan curve or fan profile is literally a kind of a verbal representation of the line graph that you see on the actual fan profile or fan settings, which you'll see as we go into it on the computer, which I think this is probably a good time we go over now and start explaining some of this. Okay, so here we are in the MSI Click BIOS. This is for the MSI B760 Tomahawk. Yes, 650, sorry, getting confused with all these names. So in order to set up your fans, the first place to go is into the BIOS. Now, if you don't want to use software to control your fans, you can make all your settings here in the BIOS, and those will work in Windows as well. But I would generally strongly recommend setting up your fans in the BIOS, and then also you can fine-tune them within Windows after. At least then you know you've got the correct settings. So in this particular instance, we want to go into Hardware Monitor. This is where we monitor our fans. So we've got all of our controls here and settings, etc. For some people, it might be a little bit overwhelming. There's a lot going on here, but we'll try and go through it step by step and try and explain some of these things and what they actually mean. So we are currently set in fan control here on CPU 1. So this is the CPU fan header, which we've currently got our CPU cooling fans attached to. Now, to make things slightly more complicated, in this particular instance, we are actually using a radiator or a all-in-one cooler. So this uses liquid and a radiator in order to cool the CPU. So this actually has two components, one of which is the CPU fans attached to the radiator, which we can control, but we also have a pump. This is what is pumping the fluid around the radiator in order to circulate that and obviously take the hot water from the CPU area and out to the radiator fins. If you're using a standard traditional air cooler or tower cooler, then we're only going to be referring to this. If you're using water cooling, then both of them do have kind of a bearing on each other. So let's start off with the pump to begin with, because this is probably something which we're not going to have to touch on a great deal more. So the pump, if we click on pump, you can see here we are currently in smart fan mode. Your system may or may not have that. And this section here with the dots and also settings on the side, we've got RPM, which is on the side here, and on this side on the left, as you can see from the temperature gauges there, this is going to be the temperature that the CPU will reach, and these dots plot out the RPM of the pump. So in order to explain that, if we move this down here, so this pump is a 3-pin version, so as you can see on the side there, it's going from 0 to 12. So that is standing for voltage, as we said earlier. 3-pin fans work on voltage control. We don't have PWM control. So if we start off at the bottom here, as you can see, 0 and 0. So we've got 0 on the left axis, 0 on the right axis. So this means, or equates to, if the processor CPU is at 0 degrees Celsius, the pump will put 0 voltage into the pump, or the motherboard will put 0 voltage into the pump. So obviously that is probably not ideal, because that would mean the pump is stopped, so you have still water, which you probably always want it moving. Now for most water pumps, I would suggest having them pretty much at 100% as much as you possibly can, if you can bear with the noise, and just keep the fluid constantly slashing around the system. Some people may not like that. You may want to adjust it. So this is what we mean by adjusting the curve. Now it isn't actually a curve, this is more of a straight line, but this is what is known as the fan curve or fan profile. In this case, obviously, it's the pump profile, but the two are kind of interlinked and they both work in the same way. So if you wanted to make a fan curve as such, then you could do this. So this is a gentle curve swinging gradually upwards as the temperature increases on this left-hand side. So we're starting off at roughly about 50 degrees Celsius. As we get to here, which is about or 60 degrees Celsius, we've moved the line up, or the bar up, or the dot up, and we're increasing the speed of the fan. As you can see, here are the fan speeds here, or the pump speeds rather. Hopefully I'm explaining this in a way that kind of makes sense. So if you wanted low noise, you have these lower, and the lower velocity of the fluid in the pump generally will equate to higher CPU temperatures in general. If you increase the pump's water speed, then in theory your processor should be cooler. Now that's not entirely always accurate because there are slight differences in how some pumps work, and it isn't always best to have your pump at 100%. It depends on the individual pump and the efficiency of the radiator, etc, etc. But it's a bit much to go into in this particular video because we're going to be trying to cover a lot of things, but hopefully this gives you some idea. So a fan profile or a fan curve is what we adjust in here, and as you can see it relates there. At the bottom we've got these two graphs. So the green one, or pale green, whatever color it is, this is telling you your fan speed and it's plotting it out, and the one at the top here, the white one, is for this here, which is our temperature. So although these aren't at the top here where the actual curve is because of how we set it, which obviously if you drop things down, so if we drop things down, we should see now a direct responding thing with the pump. So this is our pump fan, or pump, whatever you want to call it, the AIO impeller inside the motor. So as we draw this down, it's getting less voltage, and you can see currently at that point there it has stopped, which is generally a bad idea, so you don't want that. So I'm going to put this back to how I normally have mine set, generally quite high or 100% depending on the temperatures, etc. Also, we've got this option here for smart fan mode, so you can turn that off if you want to and it'll just do its own thing. Smart fan mode is basically a loose way of saying user control mode. So hopefully that makes sense and you understand how that works. So if you turn that off, it'll basically just probably go 100%. If you have smart fan mode, you have user control. That is that section. Over on the left hand side on this particular instance, we've got the option for our actual connection. So as I said, this is a 3-pin DC pump. So we have our DC mode selected. If we went into PWM, it wouldn't control it accurately because it's looking for a PWM signal which does not actually exist on the header. There physically isn't a pin to provide that data. So it's very important that you set up your fan header in the appropriate way for your particular device. Also, options we've got here on this particular instance is our temperature source. So we can choose, if we want to, various temperature sources. So for this we want to register our CPU core because this is a CPU cooler. The pump is spinning or pushing fluid around at a rate which is dependent on the CPU core. If we're monitoring the system temperature, that is the kind of ambient temperature inside the case, depending where the sensor is on your motherboard, it wouldn't be given an accurate reading of what our CPU is doing, and it doesn't make sense to do it that way. But for fans, it may well make sense to choose system or chipset. So hopefully that gives you a better idea. We've also got our fan step up time and step down time. So this can be translated to ramping up or ramping down, or how quickly the fan reacts to the actual increase in temperature. So currently we've got it set to 0.1 second. So as our CPU spikes in temperature, the pump is going to react very quickly. So if we change that to a lower degree, 0.7, it's going to take longer for the pump to react. Now for some systems you may find that your fans are going a little bit haywire, spinning up, slowing down, spinning up, slowing down. So in that instance you may want to change these a little bit so it doesn't react immediately and it takes a little while. So that will possibly even out your fan speeds. So anyway, hopefully that all makes sense there. Obviously there is a graphic on the side here, or tells you basically what has happened. So for our fan, 12 volts at 79 degrees Celsius, this isn't the fan or the pump temperature, this is directly linked to the CPU temperature. So when our CPU temperature is at 23 degrees Celsius, it will only put 10 volts into the pump, so therefore spinning it slower. As the temperature of the processor increases to 49 degrees Celsius, we add a little bit more voltage there, up to 11.52 volts. And when we get to 79 degrees, which is our threshold, which you can set yourself however you want to, depending on this. So if we move that down, you can see those figures all change as we do accordingly. But ideally, you want to set some sort of threshold. So 70 degrees, I want my pump going at full speed to try and reduce temperature. Anyway, so that is that one done. So that is for water cooling pretty much only. We're going to look at the CPU now. So the CPU is going to be very similar. It works in exactly the same way. We've still got our smart fan mode or user control mode, but now we've got some options here. So we've got PWM, we've also got DC, and we've also got auto. Now, if you know exactly what type of connection you've got, so for our CPU fans attached to the radiator or attached to your tower cooler, if it's a 4-pin, select PWM. If it's a 3-pin, select DC. So our fans are from Thermaltake, the Tough Airs, and they are PWM controlled. So we choose PWM, and again, our temperature source is still going to be our CPU core. So this is where we get our section on the left, and this is our RPMs here of the fans themselves. This particular instance, the fan RPMs here don't actually make a great deal of sense. They're very much wrong, but the principle still applies. So as this dot here, as we go up in steps, as the dot goes higher, that is basically your percentage. So at 100% at around about 70 degrees Celsius. So when the CPU is at 70 degrees Celsius, it will then tell the CPU fan to spin at its maximum speed possible, 100%. So as you can see on the side here, this is our curve, or our user controlled settings, or fan graph, or fan line, however you want to explain it. So in this particular instance, we've got it set very low here. So when the CPU is very cool, i.e. around about 20 degrees Celsius, the fans can slow right down. This will reduce noise and make living with your PC, if it's on your desk next to you, a little bit more bearable. If you increase all of these to increase the cooling, then you will get an increase in noise level because the fans will be trying to spin faster. And as you can see on this green line here, which is our fan RPM, you can see now this is gradually climbing. This is all in real time. So our CPU temperature is remaining quite constant, although it is starting to drop a little bit now. As we've increased the fan speed, the CPU temperature will reduce. Conversely, if we drop the fan speed to a lower setting, then the CPU will get hotter. Obviously, depending on your noise threshold and your own personal preferences, set this how you want. I generally find that if I do 100% at 70 degrees and 60% at 60 degrees, 40 at 40, roughly, and then kind of 20 if your fans will do it. So this for me generally gives me a nice balanced cooling solution. So the fans are quite slow when it's cool. As it warms up, it gradually goes up, and as we get to the 60 degrees mark, it ramps up or shoots up or increases the fan speed to compensate for the higher temperatures. Now if you want to, you can just do that as a straight line, so it gradually goes up. Again, this is entirely up to you and is completely user configurable depending on your motherboard and also the fans and also how you're actually connected. Again, we've got the same options for temperature source. Now, because these fans are directly affecting or affected by the CPU temperature, obviously we want to monitor the CPU core temperature. It makes no sense to monitor anything else. So there you go. Same thing applies again, fan step up time and step down time. Those are all exactly the same as they were previously. So let's take a look at the actual system fans themselves. So this is on system fan header number 2. And these are PWM fans that I'm using in the computer, and also we've got smart fan mode enabled. So again, we've got a very similar kind of graph here. This again is relating to the same things. So roughly we've got the temperature on the side here, so around about 20 degrees. then we plot up to about 40, then 60, then 70. So the fan curve or fan profile or fan speed settings give off a slight curve, so almost like a mountain or something. So it gradually goes up, then we're a little bit steeper here, and then this final bit here between 60 degrees and 70 degrees, we ramp up or increase the fan speed much faster than we do here. Although if we wanted to do it slower, we could move that along. So we're looking for a higher temperature. Again, hopefully this will make sense. I know that some of this might seem a little bit like I'm teaching granny to suck eggs, but there are people out there that don't fully understand how all this works and the relation or the kind of technology or the wording. So I'm trying to do the best I can here to make this as simple and as explained in depth as possible. It's not going to be very concise because we're probably going over a lot of things, but some people do need that extra hand holding. So if you like this video and you're getting information from it, excellent. If you're finding this a little bit slow and boring, then I do apologize, but there are people that need a little bit more hand holding than others. So there we go, there is our fan control. Again, if we want to, for the fans, we've got the option for our temperature source. So in this instance, we might turn around and say, well, the fans in the system, although they do help keep the CPU cool, our CPU cooler and the AIO pump are basically taking control of that. So if we wanted to, we could actually say we'll go with the system temperature or the chipset. So the chipset is in the bottom right-hand corner of your motherboard, and that potentially might be not getting as cooled as well as the rest of the system. So you may want to make your fans go faster or react to changes in system temperature. That again is entirely up to you. I generally go with CPU core purely for the reason that if the CPU core is getting hot, that is the kind of the heart of the PC. So you want to try and keep that as cool as possible. And I like to have my fans relatively in sync. So as the CPU core temperature increases, the CPU cooler increases in speed, the pump increases in speed, and to obviously push more air into the system, it's good that our system fans are doing the same. So that is how we set up the fans actually in our BIOS. Now this, you can completely leave this as it is, although you may find that some fans don't always find their high and low spots accurately, especially with PWM fans. It may not get a accurate reading from that chip. So let's head over into Windows now and we'll take another look at the MSI Center and see how these settings reflect into the software and how we can configure it slightly more to our own personal preferences. When you come out of the system, and it'll say, do you want to save configuration? So it's going to give you a readout there, giving you some idea of what is going on. So it tells you here, CPU fan level 1 temperature, and it gives you a 0 to 20. So this here is basically your fan speed in terms of a percentage. So at CPU fan level 1 temperature, which is again predefined in the BIOS, how we did just now, it's just giving you a readout of that. So you can kind of ignore these because these are just telling you exactly what you've just done, which you already know. You can see here, we've got in millivolts here, how many millivolts we're changing on the pump fan, because this is done in voltage rather than a DC. Anyway, let's reboot the system, go into Windows, and we'll go into MSI Center and take another look at this. Okay, so we're back into Windows, and for the MSI motherboards, we have the MSI Center. There's a little icon down here. You may find it also in your start menu, but let's go ahead and click on MSI Center and wait for that to load. So MSI Center, depending on what you've used previously, will load up the last used application as part of their suite of software and features. So let's head into features, and we want user scenario, which really should be called fan control, but that is basically what it is. And here we've got our options. So if you want to, you can just set one of these 3 existing profiles for your fans. So you've got extreme performance, which will basically make it loud, but try and cool as best as possible. Balanced, which is obviously somewhere in between. And then you've got silent, which is basically, it's going to try and keep your system very quiet, but it may increase the temperatures. So you can choose one of those 3 if you like, but if, like me, you like to customize, you've got this cog here, so you can click on the cog here and you can customize further. So you've got some other settings here. So motherboard DRAM, we'll ignore those for now. But we've got our fan settings. So each one of the fan headers or bits that you can plug into on the motherboard has its own individual control. And we've got our CPU fan. In this instance, it's our radiator fans because those are replacing our traditional CPU fan. We've also got our pump and system fans, etc. as previously. So let's go into our CPU fan to begin with. So this is basically giving you a kind of exactly the same as we had in the BIOS, just a slightly more finely tuned version of it. So smart fan here basically means PWM, or granular control. Whereas if we go to manual fan, this will assume that we're using the DC voltage and will give us an option to run at 100% DC voltage, 75% DC voltage, 50% DC voltage, or 25%. And you can possibly already hear that the fans are ramping up because they're a little bit confused by this because they aren't DC fans, they are PWM or smart fans. So if we go back into smart fan here, and we can see the fan had ramped up to almost full speed and is currently dropping. So this is a real-time display. This, as you can see, this is now dropped. So this is the actual fan speed. So currently it has leveled out here at just below 40%. So if we follow that line along to about here, on the bottom we've got our CPU temperature. So CPU 0 degrees, CPU 100 degrees, and on the left hand side, like we had previously, we've got our fan speed in a percentage. So it would have been nice actually if they'd have put this into RPM. For these particular fans, I think they still spin at 2000 RPM. So it would be nice to say 2000 RPM, but it's not, it's just saying 100%. So take that as you will. So basically you've got the same sort of thing. So we've got our settings which have been transferred from the BIOS, but perhaps you maybe find that this is a little bit too aggressive a curve. Now when I say curve, again, it isn't a curve, it's a line, but it's a profile or basically a graphical user interface version of the settings we've done. So if you wanted to make it a curve, then you could lower this down slightly. So now we're getting a more gentle swooping line. Whereas if you just want it to be directly or linear, then you could do this. So now the fan points are all in a straight line. So as the CPU temperature increases along this bottom line, the fan speed is going to increase along with it up to that 70 degrees mark. So as you can see there, 100% fan speed at 70 degrees Celsius. Now again, just to clarify, this isn't a fan temperature, this is a CPU temperature. So it is a fan speed in relation to your CPU's temperature. So just to doubly clarify, triply clarify, so this means that when your CPU is at 20 degrees Celsius, your fans will be spinning at 20% of their total RPM range. If we move this up a little bit to increase our cooling potential, so at 20 degrees Celsius now, our fans will spin at 30%. Now if you want your fans to run at full speed all of the time, you can move these all the way to the top, or as close as you can get to the top. So now our fans are going to ramp up or increase in RPM because we've told it that at all of these temperature ranges, these are the speeds we want the fan to actually be spinning at, which is getting noisy, and you can probably hear, and you can see from our green line here, this is our fan speed. So currently we're at 100% pretty much. So if we drop these down, you have to do them, you can't do it in the middle because obviously it's a line. So we can go down to 10 and drag all these down. So now this is an extremely aggressive curve. So this would be useful for extreme silence. So the fans are going to spin at very, very low speeds until we get to around about 65 degrees Celsius. Then all of a sudden the fans are going to ramp up or increase in speed as the CPU temperature goes between kind of 65, 66, 67, 68, etc. And it will move up this line. So again, I generally, for fan testing and for my own personal preference, I do 20-20, 40% at 40 degrees and 60 at 60. So that is 60 degrees Celsius would equate to 60% of our total fan speed. And then 70 degrees Celsius is 100% fan speed. Now, if your fans aren't behaving in the way that they should do, or you're finding that the RPM range or the PWM range isn't quite what it should be, you can click on the fan tune button. So what that will do is it will spin every single fan in your system that is connected at its highest and lowest points, and it will recognize those high and low points and then allow you to adjust in between those. It won't ever allow you to adjust below or above the highest rated sections. Hopefully, again, that makes sense. So that is our CPU fan. Now in this section we don't have an option to change what we're monitoring, because obviously this is a CPU fan. It's designed to cool the CPU and it is designed to react to CPU temperatures and nothing else. So let's go back and go into pump fan. Now this again, because this is a 3-pin DC pump, it's using voltage, so we can choose smart fan, because that is a clever thing that MSI and some other motherboards do. They will actually try and give you a PWM style adjustment with a DC controller. So if I want my pump to go very slow and reduce noise and reduce water flow through the AIO, and AIO stands for all-in-one cooler. Basically it's a combination unit which is factory sealed, so you have a pump, some fluid and a radiator, and it's all created at the factory rather than being a custom loop, which is a loop of water going in one end and coming out the other and going through various different pre-made or custom built sections. You probably don't need to know that, but some people are going to want to know, so there you go. So there is our pump is now running slower, it's quieter, but this means that our water is traveling through the system in our water cooler a little bit slower. So much like your radiators at home, or if you turn on the hot tap, or the slower the tap is running, the hotter the water is if it's coming from your boiler, because it's got more time to heat the water in that particular area. If you turn your taps on full blast, you'll probably find that the hot water comes out a little bit cooler because it's passing through the heat exchanger much quicker. And the same is exactly true with your CPU cooler, that if you send the water through very fast, it doesn't get enough time to actually make contact with the CPU fins or the radiator fins or the pump fins, whatever you want to call them. So there are pros and cons to each setup. I generally like to keep my pump going pretty much full speed. Sometimes this will actually reduce wear because you're not changing speed constantly. Anyway, I'm digressing. So you can set to manual fan or smart fan, again, depending if your hardware supports it. So that is our pump. And again, we can go into our system fans. Now these are plugged into system fan header number 2. So again, we can go into here. Now we've got the option here, so we can monitor something else. So we can do our chipset temperature if we want to, our MOSFET temperature, which is your VRMs or your voltage regulator modules, which are near the processor. Those are quite important to keep those cool sometimes. So if you've got a fan nearby them, you may want to control that directly. Now we've actually got a warning here as well, saying, warning, system fan RPM might behave abnormally if you set the fan speed too low. Now what I said earlier about the fans, so they have an RPM range or a PWM range. The Zodiac fan, if I remember rightly, was a range of 600 to 1800. So if we try and set it below that range, the fan may stop, or it may just stay at 600 regardless. It's basically them giving you a warning saying that you should try and set your fans to a setup that they are actually capable of doing. Now for this instance, I've made my fans a little bit cooler or quieter. So we've now got 70 degrees at 50%, and we don't go to 100% until we get to just over 80 degrees. So in this instance, this is making the system overall quieter because our curve or line or graph is a little bit less aggressive and more lenient. If we wanted to make it even more quiet or less noisy, you can flatten these lines out. This will have a direct influence on other components in your system, such as your graphics card and other things, possibly even your CPU cooler, if it relies on fresh air being pumped in, depending on what the airflow is like on your case. But this will make it certainly quieter. But as you can see already, we've got a very slight jump in temperature there because the fans are spinning slower, there's less cool air being pumped into the system, so the CPU is getting slightly warmer. And you see it's dropped a little bit there. So this case has got particularly good airflow, so it isn't as important. But if you've got a case with very poor airflow, then you want your system fans ideally to kind of counteract that. So by increasing the curve or increasing the line or moving these sliders or dots, whatever you want to call them, move them slightly up, this will have a noticeable increase in fan speed and obviously should make your CPU and components slightly cooler. So I think that is pretty much it. There's probably some terms I've used which you may still not understand. If that is the case, like I said earlier in the video, please do head over to our Discord or let me know in the comment section and I will try and help you out as best I can. The whole point of this channel is for me to try and teach people or to help people come to grips with technology inside computers, etc. So if I'm not doing my job properly in the videos and there's still things you don't understand, please do get in contact and I'll try and help as best I can for those that are still a little bit confused by what is going on or my methodology or the way I'm describing things. Okay, so there you go. I'm sorry it was a very long video, but I did want to go through things and try and explain things in potentially a more simplified way. Hopefully I've managed to do that. Again, like I said, I've said it twice now, I'll say it again. If you don't understand what I've said in the video, please do reach out to us on our Discord. I'm generally available whenever I'm awake to try and help out with your questions. So if there's something I've shown or explained and it's not been totally transparent, then please do reach out and I'll try and do the best I can. There is also loads of other people on our Discord who are pretty knowledgeable as well, so you're more than welcome to ask them. So if it's out of hours for us here in the UK, then I'm sure some of our US or Australian friends will be able to jump in and help you out with your problems. If not, then please feel free to get in touch. You can also email me if you want to. That will be a slower response, and obviously you can leave comments in this video as well, and I do try and answer all of them, so please do reach out to us. But just to reiterate, I suppose the main things to come away from this is the different types of technology. Now, if you've got a Molex or 4-pin style Molex connector on your fan, which we haven't gone over here because they are becoming less and less common, those don't have any means of fan control at all. They are just a block connector which goes in. I'll try and put it on the screen so you can see it. They're not used as much these days, apart from in some very cheap cases. So we've tried to avoid that to kind of not complicate 4-pin Molex and 4-pin PWM because they are very different things. PWM and DC control are the main two. So like I said, if you're using something like this, the Corsair SP120 RGB Pro, this uses a DC controller, so you're adjusting your fan speed with differing voltage. If you're using something like this from Arctic, then this will use PWM and basically do the same thing, but the PWM controller basically takes the voltage and does what it needs to. Hopefully I've explained this as best I can. There's going to be things I've missed out. I appreciate that. So please do get in touch. But I think this is going to wrap this one up. It's gone way too long already. If you've liked this video and you found it helpful or useful, please smash that like button. If you've got any comments or questions, stick them in the comments section below. I will try and do this video as well on other motherboards as well, just to give you a little bit more of a wider gamut of information out there. Obviously the MSI setup is going to be slightly different from those from Asus and ASRock, Gigabyte, etc. But the kind of principles are very similar, although the graphs may be slightly different. So do check the graphs to see what they actually mean. And again, if you're not sure, please do get in touch. So I've been Mike, this is Mike's Unboxing Reviews and How To, and hopefully we'll catch you in the very next video. Thanks for watching.